Thank you everybody for coming today. A few more people will arrive late because it is 2 o'clock on a Friday. Some people have other jobs, so they cannot leave as early. But thank you guys so much for coming today. It's more of a very informal Noradet Startup Day where we're going to hear from some of our companies that we have in Noradet Startup. They're going to be talking a little bit about their startup, some of their problems that they're currently facing. Hopefully they will be able to get some good feedback from you guys as well. Afterwards, we will have pizza, free pizza. That's always a winner on a Friday, isn't it? Yeah. There's soda and coffee and tea in the back as well. And then afterwards, we'll have a conversation where, of course, you guys will have the opportunity to introduce yourself as well, if you want to do that, where we can have a bit of a discussion as to Noradet Startup, where we are today. We are in vast growth as well. There are more and more startups that are seeking themselves to the Noradet Startup community. And of course, it's very important for us that we focus on creating the content and also the activities that you guys see. So whether or not it's the startup day, so you can come together and share the companies that you work for, the problems that you're currently facing, or if there's any need for competence, if you're interested in the borrow researcher scheme or looking for interns, any resources that Noradet Startup might be able to contribute with. So we'll have a short discussion on that where, of course, yes, I would like to hear from you guys. But before we do that, I would like to introduce our first speaker today. He is a researcher in the Noradet Startup community. And Sasha Anisimov, he is a researcher from the University of Oslo. He is moving into his second year of his PhD, but he also has an inspiring startup idea that he's currently working on. So, Sasha, yes, the floor is yours. Just give me a second and I will. There you go. If you have a device.
I mean, I can do it. Yeah. So thanks for giving me the opportunity to give talk today. I'm Sasha. I'm currently doing my PhD and I will start my second year of PhD quite soon. And I'm doing PhD in biomedical science. So basically, we work in the field of Alzheimer's disease and aging, and we trying to understand some molecular mechanisms of underlying Alzheimer's disease and aging as well. In addition to my PhD work, I also do a startup campaign running app and blood testing. So we're trying to understand the current stages of the body based on the blood biomarker data, and then to adjust the training program to some specific some people. So today I will give you a talk about this idea and why it could be important for many people to provide training. Yeah. 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 Great. So what kind of problem we want to solve? I think currently we have multiple apps for running and fitness in the download and play or app store, but most of these apps, they don't take into account your personal characteristics, like personal features of the body. Like they don't know the chemical profile, they don't know how exhausted you are, they don't know how many races you actually need. I think that's actually a big issue because, like, from my own perspective, I downloaded a few running apps because I've been running as well, and I was trying to be prepared for half marathon. And after some progress, I just realized that the program was provided, like, from Nike running app, for example, they don't, they completely unpersonalized. So whatever I got in that app, I usually do completely different things because I realize that the program they provide to me doesn't fit me well. And I think that's really a common problem right now because if you want to look for any kind of running program on the internet, you definitely can find something that fits you, but it takes time and finally to prepare it for the big distance, you can get injured. So it takes some weight anyway. And I think one of the possible solutions is we can analyze the data of the body. For example, blood data, like the biochemical profile. You could also analyze your sleep quality and basically some physical data like how you run, what the speed that you're running. And taking all this information together, we could provide much more precise planning program compared to what we have now. So our approach is actually based on a few articles. We try to focus on what kind of biomarkers we could analyze in order to understand the current status of the body. And based on our research, we focus on a few articles and some biomarkers, which is quite important to understanding the current status of the body. Plus, if you analyze some data from wearable devices, there's some basic things like the distance and the speed of the run, the training. It could be also quite interesting to combine this data and to draw some complex conclusions. And the main thing in our idea is definitely the algorithm, which could predict what kind of changes we need to make in the training program in order to make it more personalized. So that's the solution and approach we provide. And in our team, currently we have 5 members, 3 software engineers, and 2 biologists, including me. And we have some expertise in AI, but at the moment we don't have some AI specialists. So we would like to be open for any recommendations, and if you're interested in our ideas, let me know and we can discuss some things regarding the algorithm we're going to use in them. So here you can see a few groups of biomarkers, and basically focus on 30 biomarkers so far, and they're based on our literature search. So you can see here that we focus on endocrine status, basically hormonal level, muscle status, which is probably one of the most important groups when you track people for a long period of time. Nutrition status, endurance, inflammation, and risk of trauma. So always, if you analyze all this information together, we could find some patterns, and these patterns were already published in articles. And we just basically need to analyze this information, make the conclusion about the current status, and then make the predictions, what kind of direction we need to, how we should change the program in order to make it more personalized. And in the first version, we're going to use a few options for users. Of course, like most of the people with this one for fun, they don't follow like any specific goals. But in order to get the good data and track everything to hand, we want to focus on these 3 programs: 5 kilometers, 10, and 21. 21 is half marathon. And we also have a few points of blood tests. So basically, based on the recommendations from the literature, for the period of like 15 weeks for half marathon, it's okay to have like 3 to 4 blood test points. And I would say, like, please plan, for example, if you can take a look at 5 kilometers, you can see that we have only 1 blood test. But definitely in the beta test, and then we're going to take the idea again, we need to include the start point, the middle point, and the last point where we can compare the data with the first results we got. So we will adjust this plan a little bit, but the whole idea is that we're going to use those 3 options, those 3 planning programs, the first version of our app, and that's basically how it's supposed to work. So first we have the whole program. No matter like what's your training background and how well you run, we could adjust like a training program based on the data, like how fast you run, how often you run, also like previous experience, and what's your goal. So taking all the data together, we can make the default program. After 1 week of training, we propose to have the first test, the first part test. So that's the first point, and we don't make any conclusions from this point because we just got the first initial data, and most of the biomarkers are actually very specific, and we can't make like some kind of average value for some biomarkers like testosterone. So we definitely need to know the baseline. That's why we have the first blood testing. After some periods, we have the blood test again. And at this point, we can compare this data to the data we got first time. And we already can make some conclusions if we find some patterns in this second blood test. And then we can adjust the training load also according to the data we got in wearable device, like distance and how people comply with the training load. So 1 year ago, when this idea came to my mind, we did a test study of our approach. We test 2 programs, 10 kilometers and 21 kilometers. And we had in total 18 people participating in our study. But I wouldn't say that it was a real study because it wasn't well funded as it wasn't like a real perspective study. And we just basically wanted to know who could be our consumers, and it was some kind of like task design. But at the same time, we realized that it would be really nice to test this idea again and to conduct real research with like approximately 50 participants in order to draw some solid conclusions. And at the moment, we basically developed the front part of our app. So we have the app, but we're still working on the algorithm. And that's why the first current task is the sport study. At the same time, we want to test the application, but the main idea, we want to invite some people to make the standard study and to test them a few times, make a few points just to check how biomarkers are changing. The next thing, we also know that there are a few possibilities here in Norway. There are a few open databases, and some PhD students can get access to this database and we get the data on the performance. So some people did running, for example, and what kind of changes in biomarkers level they have. And combining those 2 first things, we could actually make our algorithm more precise. And if you analyze all these changes in the body, we could find some patterns. We could make algorithms, make predictions based on the current technical figures. And the third thing, there are actually different types of blood measurements. So if you go to a hospital now and you want to check the level of testosterone, they would like take the testosterone, the molecule from the blood sample, and analyze the concentration of the testosterone only. But at the same time, there are some different approaches like metabolomic and proteomic. So we could have like the profile of all molecules in the blood sample, like we could analyze all metabolites in the blood based on the spectrum, I mean, just like physical methods. And then we could get the data of the whole metabolome profile. And if we check this data a few times, we definitely could draw some conclusions how these metabolites have changed. And the same we could do with the proteins. Things like molecules, that all molecules and proteins, they're different in size, we need to use kind of different approach. These things, these methods, they kind of novel, and I know a few groups in Norway to conduct study in this field, and it would be definitely nice to talk with them just to understand whether we could use this method in our study, because once we go to the first point, once we perform the sport study, we need to know what kind of method we use to get this blood information. And this, I believe that metabolomic methods would be really prominent in this scenario, because we could get a bunch of data, and at the same time we could have more solid patterns just to find the direction of the future point study. So now we're still solving these things regarding algorithm. we're open for discussion, any suggestions, any critique. So if you're interested in the idea, if you wanna talk with me about the app, then just feel free open to ask any questions and suggest any idea you have. And thank you again for the opportunity to join Nora, because I think it's a great starting point to make really sophisticated algorithm and to make one step closer to a real personalized training app, because I really believe that in the coming future, we just need to download the app, have a wearable device to get all this blood information, like Google Watch or something like that. And then we already will have an algorithm. So we just need to apply this algorithm and analyze the full biochemical profile. And then you will know how much you need to run and how many trainings per week you need to do in order to achieve the goal. So yeah, thank you for the opportunity, and yeah, feel free to have any questions. Thank you.
Do we have any questions now from the audience? Yeah. Should we start with you?
Let's stop you. What are your problems?
Sorry.
Challenges. What are your problems? What are your challenges?
The first thing regarding biomarkers, we know about what biomarkers and how to work with them. We know what they mean and how to analyze those biomarkers. But at the same time, we want to make a really solid approach, and that's why we want to conduct a real spot study. So we just want to make sure once we get this information about, like, once we get this biomarker information, what kind of decision we need to make. And this decision actually has to be confirmed by sport studies. And that's the first challenge we have. So we need to get some data from the real research, and then we need to apply this data to the app. The second thing is to access the database. So we want to get as much data as we can, I don't know, like training data, for example. People were trained for a few weeks, and they also had a few time points with blood testing. So it would be extremely helpful for us to get this information, then we could analyze this data and also make some conclusions like what kind of biomarkers we need to take a look. And those two things, they actually extremely important for the algorithm, because the main idea of the project is to get the biochemical profile and then to make the decision. So how exactly we need to make the decision it's really based on the research that you conduct, because we can just like start the application right now. Because if we, like, for example, launch our application right now and everybody starts using the application, they definitely could get some recommendations from us, but we don't know how exactly we should change the program, and we need to test this in the real research. So I think that's the main issue. And then the next, the next thing, like once we carry out this research, we'll have a bunch of data, and we will have some ideas about how to change the training programs. But still, we need to know how to apply these things to the real algorithm, like how to make, first of all, how to change the training program with knowledge of some personal information.
Maybe you should talk to Equal Innovation if you know them. They have access to that data and to which not do.
Yeah.
But find both data and actually create a program. I can introduce you.
Yeah. Because at the moment we have like the app, so we have the platform. So if we actually want to conduct a real study, we can use our application to track the data. So people will track the running, for example. They also will load some lab test data to the app, and just like would be the platform for the study. But at the same time, we need to find these people. We need to find people who are ready to run for a long period of time, who are ready to get blood test. Yeah. And just one additional thing, since I'm talking about blood testing, like in terms of some kind of market perspective, we definitely, I think, need to find a partner who could provide us with blood data. And there are a few companies in other countries who provide blood test data based on metabolomics and proteomics methods. And like in the future, probably it will be possible to contact them and to make some kind of agreements in order to get this blood test data in a little bit more convenient way. But so far, we just focus on the quality of the data. And that's why we conduct the study, and we could find some local research. Yeah, and we could find some local research group just to use the method, for example. So at the point, I think we don't actually need to make any kind of agreements with the big companies to provide blood test data, but it would be definitely useful to find some people group in this area and to get this method data.
Any more questions? Yeah, you have one?
Yes, I have a couple. The first one is, seems that you're focusing right now on revenue. How you thinking of expanding it to different types of sports that have clearly different type of movements, not just like running? Because I guess there will be different challenges. And the other one is regarding the blood tests. In my mind, the natural thing I would do is to have a blood test at the beginning, before starting, because otherwise you don't have a baseline of what the values are before starting to play. Why the baseline test in my mind is not there at the focus.
So answering the first question, I think it's much easier just to recognize important moments when you run, and it's much easier to get the data. So we know that by particularly you're running, and they just like, what kind of information we have the distance, the speed, and that's enough, right? Kind of enough. But when you do like other type of exercise, for example, workout, if you do push-ups or something like that, it's a little bit more power to process data and to analyze what kind of volume, like training loads was performed. So I think we're definitely interested to expand this approach to other type of sports, but at the moment, in order to make it more precise, we just focus on one. Yeah. But later, if we manage to get some successful data and manage to get a good algorithm, then we could move further and expand the idea of the type of sports. So the second question was about
why you're not thinking of blood test at the beginning before starting with them?
Yeah, that's a really good question. We're still trying to find the best way to track the data. But in our opinion, since we can, I mean, I wouldn't say that we're certainly sure that the idea we propose now, like the blood test after 1 week, is the best approach. So probably it's better than people just test it right after they started using app. But I think like for most users, I mean, for test study is absolutely okay. But when we go to the market, I think we should make it a little bit more convenient. So it's probably better to just give the app for people, for users, and they could test with that for a while, just try for 1 week. And then they would get the feeling like how it is, and they probably would be interested to get tested and provide the data for us. But I mean, speaking about trials, like speaking about a test study, definitely it's much better to have the first point in the beginning, and then like data later. So yeah, but we need to think carefully about it. Yeah, because if you go to the market and actually if you apply this kind of concept like first class test after 1 week, it means that we should do something the same in the test study as well. And because later we will apply exactly the same things, exactly the same approach to the market. So we need to think about it. But for the market purposes, I think it would be better to just have the test of the 1 week after you start seeing that.
Thank you very much. I mean, you can continue discussing afterwards as well.
We can.
In the break when we with some pizza as well.
Yeah, thanks a lot.
And thank you very much again, Sasha. And now it is my pleasure to introduce Yanislav Zagorov. Can you hear me, Yanislav?
I can hear you fine.
Excellent. Well, you can share your screen and put on your presentation. Yanislav Zagorov is from Arealize, one of our more new companies in Noradet startup. Yeah, presentation is up. That's perfect. The floor is yours.
Perfect. Thank you so much for the introduction. We are one of the newer companies, as in we were started 1.5 years ago. That's how new we are. And we just joined the network. So this is actually our first event with Nora. So really, really happy to see you all. Can't wait to get to meet you a bit more one-to-one, not just me speaking to a screen. I'm actually sick this week as well. So I'm doing this from my home instead of our office. So I was kind of lucky that I can join physically. All right. So first off, I'd like to start by the theme of this. This isn't a presentation about Arealize or what we do or how we do it. This is more of just a little startup story of how we got into the field and what our experience with presenting AI to a market that wasn't really ready for AI at the point we started was. So yeah, it's a bit of an interesting little conundrum. Just in general, I'd like to start with just a little bit about my background. I have a bachelor's degree in computer engineering and a minor in big data and machine learning from universities in Amsterdam and Oslo Met. I worked with cybersecurity for a few years before starting at NTNU's School of Entrepreneurship to pursue some startup ideas I had. One of these ideas was exploring how you can combine architecture and machine learning in order to lighten the workflow for architects and help a little bit with ideation. So we did a little feasibility study. We found the target markets. We developed a 5-year plan, and we got some. Oh, pardon. This is a picture of our team. Develop a 5-year plan. Got some money from public and private investors. We built up a team and are now selling our product officially. All of this did happen, and that's like the way it should happen. That's how you should do it. But it was kind of more like this, like it wasn't in the correct order or anything. Like everything kind of happened on top of each other during the last 1.5 years. We did go through all the steps and we have the money and we have the team and we have the product and we are selling, but it was super hectic. Right now we have a kick-ass team working on the problems. Our MVP is being used by both technical and non-technical users to generate early stage designs for buildings across several large Norwegian companies. So going pretty well, and it's been an interesting journey. Just a little quick introduction of what we actually do. Right now, there's a problem in architecture that's getting like a first design is typically really difficult, or it's easy, but you have to do it a lot of times until you get to an idea. So what we do is we take either an empty floor plan or a floor plan with existing walls. So say an office space is being rented out to a new customer and the old customer is moving out. We generate some ideas, and then we allow the users to pick and choose what they like from these ideas to create a floor plan that they like. This is what the end result looks like, and it's working pretty okay. Yeah, that's just no more about us. We can talk about that later if someone would like, but the general thing was that we were going into the architecture business when we started. And architecture and automation has had a bit of a difficult journey. So of course, we as software professionals or people interested in AI, yeah, you know the quote, right? Why spend 15 seconds automating something or doing something manually where you can spend 6 hours? Typically, it's failing to automate it. That's what the quote is. But yeah, always when you can spend 6 hours automating it. And that's the general idea, right? That's what we think automatically. We jump to solutions for manual problems, but that's not the case with architecture, or at least it wasn't the case until maybe 5 or 7 years ago. So before 2012, only a niche group of especially interested architects played around with generative design for automating parts of their work. So these parts was basically placing structural supports between load-bearing walls, locating pressure points, and creating interesting but really not implementable facade designs for their mood boards that they can then use and show their clients and then work on afterwards. These were boring tasks that were really nice to automate, but they weren't really critical. It's not like if they didn't automate them, they lost a lot of time. But they did save a bit of time. It showed them also that they could save some time by automating procedures, and it allowed architects to present artificial intelligence or generative design to other architects, right? So architects presented it to architects. It wasn't the tech people. It wasn't, I don't know, it wasn't some sort of big tech company or a small startup that started it. It was architects doing it for architects. And it kind of lessened the feeling that you're having geeky tech people push AI into your field trying to replace you. So yeah, the tech world took a look at that, adopted the approach, and now virtually every single architecture startup is heavily involved in the architecture community and heavily adapts their ideas from their designs, no matter if architects are the main user group or not. So this has been the general flow of things. So for the past 500 years, people have been going from ideas to paper, right? Like before you just built kind of a house, but architecture started as a field around 500, 700 years ago. And then we went from paper to pixel 70 years ago with CAD, computer-aided design, and allowed us to share designs digitally as well. And 20 years ago, you started automating the simple processes that I mentioned like a second ago. Yeah, and now, maybe 5 or 7 years ago, as I mentioned, you have this. You have tools like Grasshopper and Dynamo in Revit, which are basically generative design tools for architects. And it's architects using them, and it's it's AI for architects, and it's an amazing shift in the viewpoint, because 10 years ago I've talked with architects that have been in the field for a long time, and building engineers and people, researchers and everything. It was impossible to get it through. Like, you presented the idea and people were immediately shutting you down, and no, you can't create an initial design. You have to talk to the customers, whatever. And of course, that's a valid point. But these tools have shown that you actually can. You can reach an initial design, and you can reach a good initial design, and it helps the design process if you do it this way. So doing it this way, startups started taking the same approach and used architects to present their ideas. This allowed them to gain the trust of the architects and allowed the architects in the startup to present the ideas in a way that the external architects that are being presented with these tools could understand. Yeah, so that's the basic idea. Now people love generative design. It's something that is coming in the field of architecture. It's going to be a big change. And people love it. People have adopted it and are starting to use it. And there's like a bachelor and master thesis that are just all about that. And everyone seems to like it. And not everyone, I'm sorry, that's an over exaggeration, but people are accepting of it. And it's nice. It's really great to see. And it's really promising. And you have, of course, tools like Dolly, or this is either Dolly or the Imagine one. I don't remember the name. Whatever. Using tools like this in their feasibility studies to present clients with like initial sketches just to check, right? So maybe you're an architect and you like, okay, I really like the use of orange in buildings, and then you present your client with this photo, and then you say, okay, what do you think of this? Would you like the colder colors on the bottom, or do you like the lighter, warmer colors on top? Yeah, it's you can't do floor plan design, for example. It's a bit more difficult, but you can do like simple feasibility studies, or we'll be able to really soon with those. And that's what we do in Arealize as well. We showed this floor plan basically, but it's a bit more of a structured process with us. It's not the CNN just doing it. I don't know why I brought this picture. I just thought it was interesting. Of the U, because I can't be there physically, so I'm just imagining what you guys are seeing. Okay, so to wrap it up, the concrete suggestions, we've spent the last almost 2 years like studying how this process happened from A to B and how we fit into the whole story. We have one architect on the team today, one more is joining next week. We're adding people that are understanding the market and are, yeah, we think we know how we should do it now. So the first step is realize that AI and even machine learning is a scary concept to people that aren't exposed to it. Many people view AI as the Terminator. That's their idea of what AI is. And it's like a Terminator that's out there to completely replace them. And that's not what we're aiming for. But that's what it looks like on the outside. So sympathize with people, show you sympathize, and try to present your ideas in a less like bam way. That's my next point. Wait, nobody's out there, like we're not out there to automate an industry out of existence. We're working with AI in order to automate menial tasks and to improve the results from difficult tasks. So this is basically exactly what architects want as well. They want to do these things, but it's something most every startup working with AI and architecture prior to 2015 failed to explain, because they couldn't simplify their ideas. They couldn't explain what they actually meant. So just dropping AI as like a term in people's laps, that's no good. And that's what the early companies that actually succeeded in introducing AI for architecture did. They simplified and they signaled what architects could use AI for. It's just programs mostly making generic suggestions based on examples. That's what it is. It's making an example that you can use in your mood board or like a little case study to start to like kickstart your design. And that's what the startups were building. They were building basic early case study tools, but were presenting them as amazing futuristic AI solutions that could go from concept to finished product without involving a human, which you just can't do. It's not possible in this decade. And there's no point in presenting the entire solution. You just have to show what you can do now. Okay. Finally, don't push. It's really easy to fall into this mindset that automating and implementing machine learning or AI into new fields, like fields that don't have it, like construction, for example, is the future, and that both startups and researchers alike, like we all consider this as a given. Like we consider that that's probably going to happen, probably. And we try to preach this to other industries, but that's not always the case. You should provide people, like people who aren't familiar with AI, you should provide them with the information and the tools, and then let them decide if they would like to try it or not. You can't really force change, and you shouldn't try it because people are really aversive to it. Okay, so that was all I had like to present. That's been our general experience with introducing, or not introducing, or like analyzing how people introduced AI into this field, and now we're trying to replicate it as well and go into the market in the same way. It seems to be working. Just being sympathetic and having like a understanding that there's like they are humans, like on the other side of the table as well, and you are trying to help them, but the idea that doesn't always come through, and it's something you have to be like really cognitive, like you need to think about it and also communicate it externally. For our end, we are looking for researchers interested in construction, BIM, and architecture to work on research projects we are setting up with SINTEF. And we also have an intern position working with 3D visualization in web browsers, which is more focused on testing out shaders and different visualization techniques in the browser. So if any of this sounds interesting, or you just like to have a chat, or in the architect market or whatever, just hit me up. Thank you.
Thank you. If you would like to read more about the call for researchers and also the IPN project that they're planning, it is published on the Weather Startup under news as well. There are many startups right now, Iris.ai included. They're currently looking for partners, but also collaborations across in this current startup world. Yeah. Do we have any questions for Yanislav from the audience? Daniel?
It's not necessarily a question. I'm an architect, and I've been working for 20 years in the field, and I've been working also with Dynamo. I think that there were many more problems and issues why this has not been adopted by the architects, and the problem is much more complex. But I totally see it. I think that you say that this decade is not going to happen. That I think that is going to happen this decade. That the architect is going to be replaced on a lot of tasks. Like the programmers are going to be replaced by a lot of AI. So I think that we are facing a development that is much faster than we have ever imagined. But what I would like to add as a comment is that on the opposite of a lot of other fields where AI is used, in architecture is going to be to generate something that is going to outlast us. It's going to be there for decades. So therefore, the problem is still very complex. So the plans are much more complex than a floor plan. You have technical installation, you have upgrading, you have time development. So I think that there are so many layers of complexity that it will be too quick to decide that generating an AI floor plan, we can build architecture. It's much more complex. So I think it's really amazing. I know another company that is doing the same. We were trying to do the same, but we decided to let the others to do it, and after that we will implement it. But if you want, we can have a chat because I think it's really cool. But the danger, if I would add the fourth topic there, don't simplify it too much because architecture is the built environment is extremely complex. It's not just about a set of 100 parameters, it can be thousands. So, but it's really cool what you're doing. So, yeah, thanks. It was, as I said, a comment, not necessarily a question.
Thank you, Daniel. And
Thank
yeah, I'll introduce you guys on email. Did you want to say something, Anisimov? Or?
Please do. No, like definitely. Yeah, I'd like to have a chat afterwards.
Look
Thank
at that
you.
connections happening.
Yeah.
Any other questions? We have time for one short one. Third one.
I was just wondering a bit more about the company. Who are your typical customer?
Who's our typical customer?
But yeah,
Right now, it's a combination. We have architecture firms that we're working with, but it's a lot of non-technical, like real estate, the property owners, the people that own the properties and are trying to lease them out. Those are typical customers as well. So non-technical. That's the interesting part. We're making a technical tool for non-technical people.
do you also talk to or have as customer developers? Or?
No, we are working mainly with rehabilitation right now.
And the focus is on not for living, but for offices.
Yes, yeah, that's the issue we're solving right now.
Thank you. Well, and thank you very much. Then we have one last presentation. I dare point that camera at me. Daniel, would you like to take the floor?
No.
Daniel Tabacaru from AgainX. our
Of
final
course, I would like to,
for
that's
today.
why I came. among
There you
others.
go.
But I was wondering, is it possible to get the Zoom link? Because I don't have the adapter.
Of
So I will
course.
just remotely connect and share the screen.
Most certainly. Everybody close your eyes.
So you would have much more tabs.
Now, I spent 1.5 hours today at the IT support where I got yelled at. Because my computer crashed this morning because of too much.
Yeah.
I haven't done yet.
I think that the record on my computer was 180 tabs.
Yeah.
And, it crashed.
See, people are worse than I am.
Yeah, you see, there is hope that
I get yelled at him all the time as well.
what have you
To
taken?
your email.
Email.
Yep.
Good. Oh, you're asking me to start the email.
Oh, do you want it on something more snappy,
Slack.
like Slack?
Yeah.
There you go.
Because I think that I have 10 windows in my email.
Yep. Sent it now.
Good.
Feel free to have some sodas and coffee and tea in the meantime while we're sorting this out. Very in the way.
Just to be sure that I'm not connecting to audio.
I've added you as panelist so you can share screen as well.
I just have to be absolutely sure that I don't have any microphones or something.
No
like that.
microphone.
No, because the microphone is going to be on your machine,
Yes.
or yeah,
It's that fancy
So,
thing right here.
yeah.
Yeah.
I just have to. How does it work with the sound? Can you hear me, Yanislav?
I can hear you fine, Daniel.
Good. Then I will just start sharing the screen. Yeah. Good. So I should get some. Hi, I'm Daniel. I'm the founder of AgainX. I'm a trained architect and engineer, actually engineer and after that architect. I've been working 20 years in the industry, getting really frustrated about the mistakes that are done, among other things about what Yanislav said previously. So in the end, I decided to try to find a solution. And in 2020, to be more precise, on the 17th of March, 2020, AgainX has been established. So unfortunately, COVID got over, so it was a very interesting journey. In the end, it took off. So we got Research Council funding, and we won a Horizon Europe project now, that together with 5 European universities, and we got investors getting in. So now we're getting serious, to put it like this. But it has been quite a journey. But as I said, among us, the 3 founders, we have together around 100 years of experience. That sounds, no, actually it's 90. That sounds quite a lot, but that is because Eirik, our colleague, he's going to retire next year. But he has been working with the toxic materials in the building industry for a lot of years. So each of us are covering different areas, but so we got really frustrated, to put it like this. So what we're trying to do is to solve one of the biggest problems in the building industry, namely that a lot of decisions are taken by excessively minimizing the data that you take in, because you want to minimize the risk. So that means that you start evaluating complex problems just looking at 5 parameters. like in the building industry, that means the market price, what the market wants, what type of function, and what type of materials you're going to use for the building. And based on that, you take the decision if you are going to keep or to demolish a building, which is completely madness, if you ask me, from the not the least from the environmental point of view. But all this has to do with the risk. So what we're trying to solve is to switch the balance between the amount of data and the amount of risk in evaluating buildings. We're working exclusively with existing buildings. So that is, in a way, a simplified version. I think that, oh, okay, I didn't know what is not the same on my screen. But that is a very good image of how the buildings are being evaluated at the beginning. As you see here, that is what 20% of data means. Do you have any idea what the image represents? What about now when we are increasing the data to 30%? Can you still have an idea? 50%? Which one? Yeah. So already, but when you're getting, is daily. But that is exactly what is happening in the industry. This relation between data and risk is what causes that actually in Norway, as I'm going to present later, we are among the world champions in demolishing buildings per inhabitant. So the invisible problem, of course, everybody talks about the CO2, and that is another important topic, is that actually, as you see here, that is the total budget that the humanity had available from the industrial era on, so the last 150, 200 years. The red one is the one that is already in the atmosphere, has been emitted, and the yellow part is the one that everybody is fighting to keep and to avoid to go over that threshold in the next 8 years. So as you can imagine, it's quite challenging. But what we're trying to do, we decided not to go to the yellow, but to go to the red part. We are going to focus on understanding better how we can extend the life of the buildings and actually what is already in the atmosphere as a CO2 to make it part of the equation to reach the climate goals. Because there is much more to gain from there. So that was the invisible problem. The visible problem, as I said, I've been working in the field for quite a while, and from 2017 to 2019, I've been BIM manager for one of the biggest refurbishing projects in Norway, the Bærum Kommunegård, the one next to Sandvika. That has been finished in 1992 and demolished in 2020, which is crazy. For a building after 28 years to be demolished, that's madness, if you ask me. But always we got the same issues connected to the risk and the availability of data. So in the end, we have managed just to reuse the concrete structure, and the building is going to look next year like this, which is not very different, if you ask me, from what it has been before. Of course, a different energy class and so on. But always, we couldn't use more materials. We couldn't expand the life of what we have there because it was the risk of what is the quality of the materials, their availability, is it possible to disassembly them, what will be the cost involved, and in the end, what will be the time frame of doing all this. So because if all this data was not available at the right moment in time, the decisions were like a domino effect, and in the end, it was just the concrete structure to be reused. The problem is that because of these types of projects, every year in Norway, we're producing 2.1 million tons of waste from the building industry, which is huge. And 75% comes from refurbishing and demolishing. So those are materials that have an embedded carbon footprint, plus that they have a value, that intrinsic value and market value that we're just ignoring. So there are a lot of things that we can talk about. We don't have time because I have just 10 minutes, probably, roughly. But we are working now with one of our pilot customers, Mystad Eiendom, the one that's owned Lilleaker area in Oslo, CC West and all that. And they made a calculation that actually demolishing everything that is office area there and going to to residential, to apartments, it will cost them roughly 200 million to demolish everything and to start building. So 200 million is actually just demolishing and cleaning the site. But when they started to look at the materials that they have there and they could use them for another 20, 30 years, they found out that actually they are sitting on almost 1.5 billion kronas in value in reusability of the materials. So and that is just a small area. So if you're looking into the 2.1 million tons every year, so we are throwing every year probably 1/10 of the oil fund at the garbage bin, just to put it mildly. So you're talking about huge economical value also.
I'm very lenient on time.
Yeah, good.
Yeah, we're already 40 minutes behind the schedule, so
Good.
go ahead.
Oh, that's new. I'm always stressed about that. So thanks for that. But here is a graph that is trying to simplify a very complex problem. But if you look at the yellow line or orange or whatever color that should be, that is the decision impact in a building project. And the red line is the cost associated with that decision. And that is not just in the building project, it's in a lot of projects. At the beginning, you have the freedom of changing your mind and the sky is the limit because the budget is in the future and the costs now are very low. As the project evolves, there is an inversion of these curves. And suddenly every change or every decision you take is becoming much more costly. So that means that even if you are realizing the error that you have done early, you cannot change it because it's too expensive to change it. So you go with the error. And that is happening not just in the building sector, that is happening everywhere. Because that is how the complex projects develop. The gray line is the one that shows the amount of data that you have at the start of the project, which is quite limited. But the more the project evolves, the more consultants and data points are getting in. So the amount of data increases, and we have a sudden steep line curve here, where you get a lot of data, and you get to have, in theory, because in practice doesn't really exist, a digital twin of the building that you have there. I've been working with digital twins for a while, and I can tell you there is no digital twin, or what we have like digital twins, they are from different parents, which they are not today, but you can call them digital twins. What we are doing in AgainX, because we're looking at the data, aggregated data, existing data across different buildings and the entire building stock, we are aiming to double and to increase threefold the amount of data that we can deliver really early in the process. And that will allow us actually, you see the amount of data that we deliver actually is reached quite late in the process, and that will allow opening up a lot of possibilities in the project in the early stage. And that could be saving, but that could be also better use of the money and the cost, the budget cost. And in the end, increasing the quality. But also, our aim is that we should extend the life of the existing buildings because that will have the biggest impact. So just to put it, is that right? Oh, sorry. Just by extending, for example, if you have a building that we managed to extend with 20 years, that means that you don't need those materials that are in that building for another 20 years. And by just postponing the need of new materials, you are postponing the CO2 that gets into the atmosphere and a lot of waterfall consequences by that. So we don't have time to get into the depth of it, but what we're doing is simply said, we are collecting different data sources, we structure and classify them, and we aggregate them. And here is the important part, because we're trying to replicate what we have learned in our experience as the professionals in the field. We're trying to replicate and to automate them. So we try to build algorithms that are trying to, so neural networks that are going to replicate our neural connections. Neuralink is one of the things that probably is going to take us out of the markets, but is not really launched, so we still have a chance. Now for the moment, we have everything is presented through a dashboard, but we're looking behind the dashboard. But to make it simple, we're looking into 6 major areas: the carbon footprint of the building, the material availability, quantities, and the accessibilities. We're looking into the long-term maintenance plans, toxic materials, and flexibility. That is the module that I think that Yanislav, we're going to get in touch, because we decided that was extremely important, but we decided that actually we cannot work on everything, cover everything. So it seems that your solution might fit very well. I have a little, I think this one is a 30 seconds how the platform works. So you have access to all the addresses, but we don't have yet data about all the buildings. But the idea is to get on the building and you get this mapping based on the aggregated data that we have in our system. And you look on this early data, and that is the first level, because you can get even deeper into the analysis and take the decision based on what we provide about each individual building. As I don't know, I don't know if have I said that? No, we are. It was in a different meeting. Sorry. Because of the Horizon Europe project, we are going to open an office now in Eindhoven. So we are in recruiting the modus there. So we are going to get access also to the European markets much quicker than planned, because initially we focused just on the Norwegian market, but our aim is to go to the European one. And so we start to look already into different data sets and how we can make them to work together and to learn from across the sector. That is part of the team. The team, I think, has grew since last time. So we are closing now to $1 million in funding, both self-funding and private funding. It took a while, but now it's getting to be more serious. We are a very research-intensive company, so we are relying on research, but we are applied, as I say, applied science, applied research. And that is one of the questions that I have for Nora regarding this connection between research and products. Here is the plan about, those are the buildings we're working with, not so interesting. And here are the AI issues, as I call them. So one of the main issues that we have, until now, because we were bootstrapping, we were just doing small scale projects. Okay, let's try to see if we can use image recognition, if we can use ML to help us solve this problem, or to identify this building elements. Can we automate the process? What will be the bottlenecks? What are the challenges? What are the costs and all that? We have done the same looking into text and icons and image recognition, because in the product descriptions, there are a lot of icons and graphic symbols that actually have a very profound meaning, if I can call it like this. One icon can be the equivalent of an entire report about the product. So one of the biggest challenges when you're that we have faced we had a project with Google Street View to try to understand the facades, and we build algorithms that are helping us to understand the age of the building. And by understanding the age of a building, you can locate it in time, and you can place it in a typology, for example. And you can connect to different data sets that we have, and you can get much richer information by getting this entry-level, low-level information. And one of the problems that we have faced, the perspective. distortion. You have, especially when you're talking about the facades, all the buildings on the Google Street View are in a perspective. So I need some help. If somebody can help me with how we can solve the perspective distortion problem in images, how we can, if there is solvable, because probably has not been solved. I hope it is, because that will do a lot to help us with the work in labeling, automating the labeling of the images that we collect, because this deformation is extremely important. So I will present all the AI issues, and after that, I'm open for a discussion. The other major bottleneck, because of course data is a lot of data, very unstructured, different formats, and so on. But what we have learned from practice, the one that we have started the company, is that actually the details and the deviation can have a major impact on the life of the building material. So we want to avoid cleaning the data in a way that actually is going to take away all these anomalies abnormalities, and actually trying to create an idealistic image of the building, when actually we know that the failure comes from those variations that are not part of the mainstream. And that is a problem that I would like to get some feedback. Is there a way of doing cleaning that will actually keep, without using huge amounts of storage space, keep previous data sets? Is there a method where we can do that in layers that actually will allow, after we used on the clean data set, we test it, we get the result, after that to increase the granulation or the dirtiness of the data set, if I can call it like this, and do that again, and so on. Because those small details, they have big consequences in 5, 10, 15 years in the building sector. So we want to try to identify where the risk lays because of these abnormalities. So we found out that actually it's quite challenging to avoid cleaning too much the data, and so I'm open to suggestions, and we want to avoid something that I call the biggest danger that actually we are facing, after my opinion, that we are in this cleaning process, we have a tendency to build a digital twinning of reality that actually is not digital, is not identical at all. And we are building, we have access to databases that have been cleaned by somebody else in other areas of the world. And we have found out that actually those data sets, they don't really represent reality. They are like 60% reality. But our algorithms consider that absolute reality. And it's more like an ethical question. How can we avoid that actually we are building an image of the reality that in the future, the algorithms will take decisions based upon that, that actually is not really reality. So here is a big dilemma that we're trying to solve. And the third one, and I have just 30 seconds for that. We have worked both with SINTEF and IFA. And one of the biggest challenges that we have had, it was the cycle, the span of doing the research and getting to an output, testing, and getting back to it. Because and that is the problem that we have in the Horizon Europe also. The PhD positions are for 3 years, while in 3 years, we are expecting to do 7, 10 iterations. And here is a mismatch between what we need and where is the threshold to try, test and fail, and what is the threshold for a researcher to try, test and fail. So here I need also some input. If you can help me unlock the biggest secret of matching the research to a commercial cycle that is much shorter, much more intensive, and with a different error margin. So that is briefly what I have to say. I'm looking for help, questions, and thanks.
Keep getting mobile. Should we just do one or two? Do we have any quick questions that you would like to ask Daniel? Yeah.
Yeah.
The data sets, are you capturing new data or are you buying?
Both. Both. But we're focusing on the existing data mainly.